Hey everyone, my name is Chen Ziqing. Metric number is 224580. Today, I'm going to present individual assignment 1 in fluid mechanics. In this video, I will include fluid features and dimensional analysis. So, what is fluid? Fluid is a state of matter that can be either liquids or gases. They can be characterized by their physical properties such as density, specific weight, specific volume, specific gravity, surface tension, and viscosity. Fluid is a substance that does not possess a definite shape and easily yields to external pressure and unable to withstand a shearing or tangential force when it is static. Here is the classification of fluids. Fluid can be classified into steady or unsteady and compressible or non-compressible. Steady fluid is a fluid which its density remains constant at each point while flowing, while unsteady fluid is a fluid which its velocity differs between any 2 points while flowing. The compressible fluids are classified by Mach number. The Mach number between 0.3 and 1 is considered as compressible fluid. Non-compressible fluid has a Mach number less than 0.3. There are several types of fluids in our study. Here are some examples of fluids that I'd like to show you guys. The first is ideal fluid. Ideal fluid is a fluid that does not have viscosity and cannot be compressed, while real fluid is a fluid possess viscosity. Newtonian fluid is a real fluid that abides by Newton's law of viscosity. The example of elements that classify in Newtonian fluids is hydrogen and water. Non-Newtonian fluids is the fluids that do not abide by Newton's law of viscosity. Fluid mechanics is the study of physics that deal with the mechanics of fluids, including liquid, gases, and plasma, and forces applied from them. Fluid mechanics can be classified into fluid statics and fluid dynamics. Fluid statics is a branch of fluid mechanics that study about fluid at rest, while fluid dynamics is the study of effect of forces on fluid motion. Here are some fluid features that I would like to explain, which is shearing stress, pressure, density, specific weight, specific gravity, surface tension, compressibility, viscosity. Now I'm going to explain about fluid features. One of the fluid features is shearing stress. This is a type of stress that acts as coplanar with a given cross-section of material. Shearing stress in the fluid is directly proportional to the velocity of gradients and is stated mathematically as this equation, which is represented by tau equal to eta bracket delta velocity over the delta y. This symbol called eta is the dynamic viscosity, and the delta v is the change in velocity, delta y is the change in height. So the dimension will be represented by the m represent the mass, and L is the length, and T is the time. SI unit will be written as Newton per m squared. Secondly is pressure. Pressure is the force per unit area, in which it can be represented by P equal to F per unit A. P is the pressure, F is the force, A is the area experienced the force. So the dimension will be the m represent the mass, L is the length, T is the time. So m, L -1, T -2. SI unit will be Newton per m squared. Density with the symbol of rho. It is the mass per unit volume, and it can be written in the formula as rho equal to m per v. M is the mass of substance, V is the volume, so the dimension will be m times with the L negative 3. SI unit kg per m cube. Specific weight with the symbol gamma is weight per unit volume. And the formula is gamma equal to weight per unit volume. Dimensions is m the mass, L the length, -2, T will be time, -2. SI unit will be written as Newton per m cube. Specific gravity can be derived by using the density of a certain object divided by the density of the water. Another way around, we can use the specific weight of this object divided by the specific weight of water. And this is the dimensionless quantity in which there is no units represented by specific gravity. Surface tension. Surface tension is the work per unit area, and it can be derived by using the work and divided by the area. Dimension will be the m times with the t minus 2. SI unit is Newton per m squared. Compressibility. Compressibility can be written in a formula as E equal to negative delta Y per unit the delta V over the V. Dimension will be written as m times with the t minus 2. SI unit is Newton per m squared. Dynamic viscosity is an ability to resist flow and deform. Its formula is eta equal to tau times with the delta y over the delta v. Dimension will be written as L squared times with t power of -1. SI unit is m squared per second. Kinematic viscosity is an internal resistance of fluid to flow under gravitational force. Its formula is V equal to eta over the rho. Dimensions can be written as L squared times with t power of -1. SI unit is m squared per second. Now, I will delve into dimensional analysis. First thing first, dimension is a measure of physical variable without numerical values. In this case, dimensional analysis is the study of relationship between physical quantities with the help of dimensions and the units of measurements. For your information, dimension can be classified into primary and secondary. Here are the 7 primary dimensions which have been represented in this table, which is mass, length, time, temperature, electric currents, amount of light, which is luminous intensity, amount of matter. And the symbol to each dimension is the M represent the mass, L represent length, T represent the time, and the capital letter of T represent the temperature, capital letter of I represent the electric currents, and C is the amount of light. And the number of mole will be represented by N or the capital letter of N. Here are the SI units to the corresponding dimension, which is kg, m meter, s second, k is the Kelvin, a is ampere, c candela, mole, which is the number of mole. Let's move on to secondary dimensions. All other dimensions can be derived as combination of per 7 primary dimensions. These are called secondary dimensions, which their corresponding secondary units. So, here are some examples of secondary dimensions which have been included in this table, including the force, accelerations, pressure, energy, and the power. And their corresponding symbol is F, capital F. Acceleration will be the A, P is the pressure, E is the energy, P will be the power. Here the SI unit that is frequently used during our calculation, which is Newton for the force. M per S squared will be acceleration, Newton per m squared in pressure, Joule, which used for energy, W for power. Let's dive to the uses of dimensional analysis. Dimensional analysis is called factor label method or unit vector method, in which we can use for unit conversion that we use it to get the same unit. For example, 1 atm is equal to 1 multiplying the 1.01325 times with 10 power of 5 Newton per m squared. Second example is 1 meter, which can be converted into feet by multiplying with the 3.2808. Now, I'm going to explain about the principle of dimensional homogeneity, which is one of the significant features in dimensional analysis. Principle of homogeneity stated that dimensions of each terms of a dimensional equation on both sides should be the same. This principle is used to change the units from one form to another without changing the dimensions. Here are the example, represented by equation of linear motions. It can be written as s equal to u, which is the initial velocity, times with the t, the time, plus with half, 1 over 2, times with accelerations, and the t squared. So the dimension on both sides will be s will be represented by the dimension of L equal to LT power of negative 1 times with the T, which is time, plus with the L times with T minus 2 times with T power of 2. So the 1 over 2 is the constant, which don't have any dimensions. So lastly, we would get all same dimensions for these equations, which is L is length. As such, the dimension on both sides are the same, so the equation is dimensionally correct. Following by that, principle of dimensional homogeneity is used to check the correctness of the physical equations. Here is another example which include the pressure, force, and area. As we all know, pressure equal to force per unit area. Here, force is a derived quantity that can be derived from the mass and accelerations. The unit will be written in kg ms power negative 2. Its dimensions is capital M, capital L, capital T power of negative 2. Area m squared, in which the dimension is L squared. So force per unit area in dimension form will be m L power negative 1, T power negative 2. Thus, to check for the physical equations, force per unit area, we will be obtain the unit as kg times with m minus 1 as power negative 2, that is equivalent to dimensions of m, L negative 1, T negative 2. So the dimension is considered correct. Last but not least, here is the application of dimensional analysis and its limitations. Dimensional analysis is a fundamental aspect of measurement and is applied in real-life physics. So here are the 3 prominent reasons that we need dimensional analysis in life. First, to check the consistency of dimensional equations. Secondly, to derive the relation between physical quantities in physical phenomena. third one is the change unit from one system to another. On the other hand, there are limitations as well. For example, it does not give information about the dimensional constants, and the formula that containing trigonometric function, exponential function, logarithm functions cannot be derived. And the third one is no information about whether a physical quantity is a scalar or vector quantity. Here are the 5 sources of reference which I found useful in our assignments. So thank you for your listening.